Welcome to AI Frontiers, where we explore the revolutionary intersection of artificial intelligence and software engineering. Today, we're examining the AI-powered software engineering revolution through insights from 16 groundbreaking research papers published between September 21st and 30th, 2025. Picture this. You're debugging a critical system failure at 3 a.m., sifting through thousands of log entries, when an AI assistant not only identifies the root cause in seconds, but explains its reasoning step by step. These scenarios aren't science fiction. They're the cutting-edge reality of software engineering research happening right now. We'll explore everything from automated debugging to intelligent code generation, examining both the revolutionary opportunities and the security challenges that emerge when AI becomes deeply integrated into our development processes. Our journey today takes us through 6 dominant research themes that are fundamentally reshaping software development. We'll examine groundbreaking findings about AI code generation and the critical security implications that come with it. The presentation includes deep dives into 3 seminal research papers that represent different aspects of current software engineering research, each demonstrating significant advances in the field. We'll explore future directions for AI-assisted software engineering and discuss the critical implications these developments hold for developers and organizations worldwide. From multi-agent systems that generate complete applications to sophisticated attacks that can fool human reviewers, we'll uncover how artificial intelligence is transforming every aspect of software engineering practice. Computer science software engineering, formerly known as CS.SE in academic circles, serves as the backbone of our digital civilization. This field encompasses the entire software lifecycle, from writing the first line of code to maintaining massive distributed systems that serve millions of users. Modern applications often consist of hundreds of microservices communicating across global networks, creating exponential complexity that pushes traditional approaches to their limits. AI is fundamentally changing how we approach development, testing, and maintenance practices. Every smartphone app, cloud service, autonomous vehicle, and smart home device relies on sophisticated software systems that must be reliable, secure, maintainable, and efficient. As these systems grow in complexity, cutting-edge research becomes not just interesting, but absolutely critical to our technological future. The first dominant theme reveals AI-powered development and testing capabilities that extend far beyond simple code completion tools. Multi-agent systems can now generate complete web applications directly from natural language requirements. Juan and colleagues developed TDDev, a sophisticated system that automatically creates full-stack web applications using test-driven development principles, achieving 14% improvements over existing approaches. These systems don't just generate code, they create comprehensive testing suites that evolve alongside the software. AI systems are now capable of maintaining testing frameworks as software changes, automatically generating and updating test cases to ensure continued reliability. The capability to perform full-stack development from natural language specifications represents a fundamental shift in how software can be conceived, designed, and implemented. The second theme focuses on security and vulnerability detection, revealing new attack vectors that emerge in AI-assisted development environments. Liao and colleagues' work on smart contract vulnerability detection demonstrates the positive potential, using advanced static analysis to identify previously unknown vulnerabilities affecting digital assets worth over $200,000. However, more concerning research shows how adversarial actors can manipulate AI repair systems to introduce security vulnerabilities while maintaining functional correctness. Chen and colleagues' SW exploit framework achieved attack success rates as high as 91% on AI-generated patches compared to baseline rates below 20%. This research reveals how security vulnerabilities can be hidden within functionally correct code, presenting fundamental challenges to our assumptions about software security and the reliability of AI-assisted development processes. Theme 3 addresses configuration and performance optimization through revolutionary co-evolutionary approaches. Modern software systems often have hundreds or thousands of configuration parameters, making manual tuning practically impossible. Xiong and colleagues developed CoTune, a groundbreaking system where both configurations and performance requirements evolve together simultaneously. This approach achieves up to 2.9 times better performance improvements compared to traditional methods that treat requirements as fixed constraints. The revolutionary shift moves from static optimization approaches to adaptive systems that can evolve their objectives alongside their configurations. This co-evolutionary framework represents a fundamental reimagining of how we approach system optimization, recognizing that requirements themselves can and should be part of the optimization process rather than rigid constraints that limit potential solutions. The remaining themes complete our comprehensive view of the AI software engineering landscape. Theme 4 involves intelligent log analysis and system monitoring, where Liu and colleagues' R-log framework demonstrates remarkable capabilities. By teaching AI systems to reason about logs step by step, similar to how human engineers approach problems, the system achieves over 228% improvement in analyzing unseen scenarios. Theme 5 encompasses developer experience and educational applications, where AI systems provide fine-grained, explainable feedback for programming assignments, significantly outperforming traditional automated grading systems. This work suggests AI could democratize access to high-quality programming education. Theme 6 addresses code analysis and understanding in the era of AI-generated content, where researchers are discovering that classical software engineering tools, when properly enhanced, remain surprisingly effective at analyzing AI-generated code, suggesting thoughtful evolution rather than complete replacement of existing toolchains. The research reveals several critical insights that are reshaping our understanding of AI's role in software engineering. Perhaps most significantly, semantic errors constitute the majority of faults in AI-generated code, with some models showing semantic error rates exceeding 60%. While AI systems have become remarkably proficient at generating syntactically correct code that compiles successfully, the semantic correctness problem, where programs compile but behave incorrectly, remains a major challenge. Real-time intervention during code generation shows dramatic promise, with Wang and colleagues' SemGuard system achieving nearly 20% reduction in semantic errors through monitoring and redirection during the generation process. Co-evolutionary optimization approaches achieve 2.9 times better performance improvements than traditional methods. Reasoning-based approaches dramatically improve generalization to unseen scenarios, while post-analysis aware sampling techniques can capture 56% of critical traces at just 2.5% sampling rates. The sophisticated methodologies employed across this research showcase innovative approaches that combine traditional software engineering techniques with cutting-edge AI capabilities. Large language model fine-tuning with specialized software engineering datasets allows researchers to leverage vast knowledge encoded in pre-trained models while adapting them for specific domains. Multi-agent collaborative frameworks decompose complex problems into manageable components, with each agent specializing in particular aspects like code generation, testing, or optimization. Adversarial testing and red teaming methodologies systematically attempt to fool or manipulate AI systems to reveal vulnerabilities and limitations. Reasoning-based reinforcement learning teaches AI systems to follow structured analytical processes similar to human experts. Using joint reward functions that consider both reasoning quality and final outcomes, hybrid analysis approaches combine static code analysis, dynamic execution tracing, and large language model reasoning to provide comprehensive code analysis capabilities. Liu and colleagues present RLog, a groundbreaking approach to automated log analysis that fundamentally reimagines how AI systems can understand and analyze complex system logs. The research addresses a critical challenge in modern software engineering. As distributed systems generate massive volumes of log data, traditional manual analysis becomes unsustainable. Yet existing automated approaches suffer from domain discrepancy problems and information processing limitations. RLog's innovative approach centers on teaching AI systems to reason about logs in a structured, step-by-step manner that mirrors how experienced human engineers approach log analysis. The methodology involves curating over 2,000 reasoning trajectories guided by 13 distinct strategies derived from real-world operations and maintenance practices. The system achieves remarkable results, with over 228% improvement in analyzing unseen scenarios compared to baseline approaches. The reasoning-based reinforcement learning approach represents a new paradigm for training AI systems on complex analytical tasks where explainability and generalization are critical. Chen and colleagues present a sobering analysis of security vulnerabilities in AI-powered automated program repair systems through their SW exploit framework. This research challenges fundamental assumptions about software security by demonstrating how seemingly legitimate bug reports can be crafted to cause AI repair systems to generate patches that are functionally correct but contain security vulnerabilities. The sophisticated three-step process involves program analysis to identify potential injection points, adversarial issue generation that creates misleading but plausible bug reports, and iterative refinement based on repair agent outputs. The empirical evaluation reveals deeply concerning results, with attack success rates as high as 91% on functionally correct patches across 3 different agent pipelines and 5 back-end large language models. This research has profound implications for continuous integration systems and code review processes, challenging the traditional assumption that patches passing all tests are inherently reliable and secure. Xiang and colleagues present CoTune, a revolutionary approach to automated system configuration tuning that addresses fundamental limitations in current optimization practices. Traditional configuration tuning systems operate under the assumption that better performance is always preferable. But this ignores the reality that real-world systems often have specific performance requirements rather than simply wanting maximum performance. CoTune's core innovation lies in its co-evolutionary approach, where both system configuration and auxiliary performance requirements evolve simultaneously alongside target performance requirements. The methodology creates auxiliary performance requirements that serve as backups when primary requirements become ineffective or misleading. The comprehensive experimental validation covers 162 test cases across 9 different systems with 18 different performance requirements. The results are impressive. CoTune ranks as the best performing tuner for 90% of test cases, representing a fundamental shift from static to adaptive system optimization approaches. The future directions for AI-assisted software engineering point towards several critical areas requiring immediate attention and long-term research investment. Developing robust security frameworks for AI-generated code validation becomes paramount given the security vulnerabilities revealed in current systems. Advancing reasoning-based AI systems for complex engineering tasks shows tremendous promise for improving both performance and explainability. Creating adaptive optimization systems that can handle evolving requirements represents a fundamental shift in how we approach system design and maintenance. Building transparent and explainable AI development assistance will be crucial for maintaining human oversight and understanding in increasingly automated development processes. Establishing comprehensive standards for AI-human collaboration in software engineering will ensure that these powerful tools enhance rather than replace human expertise. The research landscape suggests we're moving toward a future where AI serves as sophisticated partners in software development rather than simple automation tools. This comprehensive analysis was synthesized using advanced AI models, including GPT and Anthropic Claude Sonnet 4, with text-to-speech synthesis powered by OpenAI and image generation via Grok. The content underwent thorough human expert review for accuracy and coherence to ensure the technical information presented meets academic standards. However, it's important to note that, despite careful review processes, potential oversights may still exist in the synthesis and interpretation of complex research findings. All original research references and citations are provided to enable listeners to access the primary sources and conduct their own detailed analysis. The synthesis aims to make cutting-edge research accessible while maintaining the technical rigor and nuanced findings of the original papers. Listeners are encouraged to consult the original papers for complete technical details and to form their own conclusions about the research implications. Subscribe to our YouTube channel for the latest AI research insights and join our community of researchers, developers, and AI enthusiasts. We provide weekly deep dives into cutting-edge artificial intelligence papers with expert analysis of emerging trends in AI and software engineering. Never miss breakthrough discoveries that are shaping the future of technology. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.